I'd love to begin by just getting to know each of you, and hopefully you can introduce each other to the audience. So Anne, I want to start with you because you're going to take us all the way up into space, and you're going to tell us a little bit about what Deneb's doing.
Yeah, so hello everybody, I'm Anne Battens, CEO and co-founder of Deneb Space, and what we're doing is making satellites autonomous. And this is very important for keeping satellites on track. So what we've found is that the number of satellites going into orbit is going to triple by 2030. So there's a graph there to support what I'm saying. As an engineer, I like data, so here we go. But what we actually found as well that's even more concerning than that is that 1 in 3 satellites are failing because of the current way that they maintain their orientation. So you can imagine this is a pretty big problem as we've got more and more things going into space and not many of them are working very well. So at Deneb Space, we want to help build that reliability, but also take that even further and enable them to have precision and automation as well.
Amazing. Now, Anne, I might just ask you, we hear this thing, there's lots of satellites going up into space. Who's sending them? What industry is sending them up there? Tell us a little bit about why there's so many satellites going up there.
Yeah, really good question. So basically everyone's sending them up. So there's the kind of common ones that we know like telecommunication, weather monitoring, these kinds of things. But a lot of government, defense, another really big, really cool field that we're touching on today a lot as well is environment monitoring, looking at critical systems, infrastructure, these kinds of things. So lots of stuff going up.
Great. So you've actually brought us back down from space, back down to Earth, which leads me to Clyde and Quest Robotics. So why don't, Clyde, you introduce the work? Well, first of all, introduce yourself, because you do refer to yourself as a robotics...
Oh yeah, a robotics morphologist.
A robotics
a word I made up
morphologist.
during my PhD.
Never met one before, but here he is today. But
Yeah,
why don't you tell us a bit about your background, Clyde, and what you're doing with Quest Robotics?
Oh, sure. Well, I'll explain that word first. So I did my PhD in robotics, so really on the interface between biology and engineering. And so there's a job in biology called a functional morphologist that look at the form and function of animals and try to understand why they're sort of designed the way they are. Now, in robotic systems, we sort of take a ground-up approach, right? It's very different. We think we know how they work, but we're getting so complicated with robotic systems these days that we're actually starting to borrow some of the techniques from biology for understanding the sort of why these systems should behave like they do and applying them in robotics. And that was kind of one of the themes of my PhD. So I came up with a new term for myself, robotics morphologist, to understand more complex robotic systems and why and when we should be using these complex systems.
And so how are you using that with Quest Robotics?
So yeah, Quest Robotics is really, this is what we're about. I'll take a step back. So I founded the company. So I'm Clyde Webster, if we didn't get to catch that. I founded the company last year really with the focus being safety. For me, the story of robotic systems is not actually about the robots at all. It's about us, right? And it's about freeing us from really dangerous and demeaning labor. And there is a lot of that. There's a lot of people putting themselves in harm's way to get the job done, which is great. But a lot of the younger workforce are coming through and saying, we don't really want to do that. We don't want to put ourselves at risk. Why should I put my life on the line for the work?
Yeah.
And that's where robotics comes in. It's the only sort of control that is a highest level elimination control where you can put a robot in place of the person. You take the danger out of the job and not the person. So the person still supervises and operates that robots and makes sure they're contributing their 20 years of experience getting the job done. But they're now safe. They're now able to do that job day in and day out. And eventually they'll be able to operate multiple robotic systems, enhancing their agency and capability, addressing things like labor shortages.
And you told me before the stats around workplace injuries are quite phenomenal,
Yeah.
even just in Australia. So just tell us a little bit about that.
Sure. So in Australia, we lose 1 million weeks of labor every year to injury, physical
Wow.
workplace injury. Globally, that accounts for about $1.2 trillion in lost productivity between both injury and sickness. So it's hard to split those stats up, so they just give them as one. So we're intending to address that with new robotic tools that are owned and operated by the workers themselves to enhance their capability, their safety, and their agency.
Amazing. Thank you, Clyde. Robert, all the way down there,
Hi.
quite far away from each other. But you're going to take us to the ocean. So we've been to space, we're back down to Earth, and you're going to take us to the ocean. And tell us a little bit about what you've been doing with OCS technology, and maybe even give us, where does the name come from?
Yeah, sure. Thanks, Sean. As you can see from the picture, we're building renewable energy powered robot boats that use solar and wind, which you can see there, but also wave power to stay out in the ocean persistently for a long period of time. And that's for defence and non-defence applications. The word Osius comes from Latin because my story is that I started being an entrepreneur at the age of 38. I was very happily being a country doctor in Ulladulla up to the age of 38. And I was saying earlier that halfway through my time there, they invented the fax machine. And then towards the end of my medical career, they invented the mobile phone, which was a brick. And then with a bunch of friends, we went and won a solar boat race in Canberra in 1997 because I said to the judges, look, all the solar boats are like solar cars, they just got the panels flat, but could I enter a boat where you could angle a panel to the sun at 9 o'clock in the morning and also sail? And they said, we'd like to see that. And we won the race by 30 kilometres in a 60-kilometre race. And of course, nothing happened, right? Nothing happened because who cares? But in 2000, because of the Sydney Green Olympics, I got some people who said, let's build a solar sail, a ferry for the Sydney Olympics. And so I started as an entrepreneur 24 years ago, and for the first 15 years ran a really crap company that didn't make much money, just washed its face, as the accountant would say. And it didn't have that ecosystem that you guys have got today. And I just shout out Richard Dale, who's in the audience I just caught up with. He helped us do a business model. But really, we didn't know what we were doing. But in retrospect, about 2015, we pivoted to building these unmanned drone boats. And that sounds like we knew what we were doing, but we're just following the money. And for the last 9 years, we've done a bunch of innovation contracts. And in the last 4 years, we've become a profitable company, making serious revenue.
Yeah, profitable. Let's give a hand up for that.
Thank you. So I know, anyway, we've just been announced in the the Integrated Investment Plan by Defence as one of 3 technologies that Navy's going to take forward. There's us and Anduril and another company called Spear 2. So we're the autonomous platforms that are going to be deployed going forward for the next to 2040. We've just signed $14 million worth of contracts in the last 4 weeks with Navy, and we're negotiating more. We've just sold 2 to America, and we're leasing to New Zealand. They want to buy some more. So very happy to really just congratulate everyone at Cicada for what a fantastic program you got here for the innovators, and I'm really happy to talk about lessons learned on how to run a crappy company.
Well, we're going to dig into that in a moment, but a 24-year overnight success, I would say there. Yeah, a classic deep tech story. I want to touch on something that I think you've all mentioned in your introductions, and it's something we've spoken about a little bit, is this automation. Autonomous vehicles. We know we're going to need this stuff in the future for our industries, but I think it's a term that's used frequently, but often kind of a bit misunderstood. I think it means different things to different people. I think it means different things if you're in different industries. I actually think it's a term that excites certain people and it scares the hell out of a lot of people. And I'd really love to understand what each of you mean by autonomy. And so, Clyde, I'm going to start with you. And actually, maybe you can just give us the definition of automation and then maybe tell us how it works. It's operating in the realm of robotics and the industrial safety complex that you're working in.
Sure. Well, the definition, I'm sure you can all Google it, but the etymology comes from essentially a word in Latin that just means to do something itself, essentially, to have something behave and describe as itself. Moving into the 21st century, we've come up with whole metrics to describe what autonomy is, and we've got, I think one of the most popular ones is the SAE, the Society for Automotive Engineers, levels of autonomy. This is particularly pertinent to looking at self-driving cars. So everyone imagines the end goal, generally, like robots, things doing themselves absolutely by themselves without our interaction, but that doesn't happen until the very, very, very later stages. Right, that's what they call SAE level 5. Mm-hmm. But autonomy means everything in between that, right? It's assistance, it's robots starting to do things that help supplement work and supplement labor, and very important for me, helping reduce risk, because that's the sort of first things we want them to do. Tools for ourselves to sort of free us of that labor.
Thank you. Now I know what automation means. Now, Anne and Robert, you are both operating in really complex environments, space and the ocean. So I'd love to understand how you're using automation, how it's helping your customers, or how it's helping your product development. Talk a little bit about how each of you, maybe Robert, we'll start with you.
Yeah, sure. Look, when we've got good communications, then we have a whole bunch we've got this vein of engineers and sailors at the University of New South Wales, and Tom Grimes is up the back there, who'll say good day to you later, a champion sailor. And so we can't help ourselves but interfere with what the robots are doing and try and make them sail better. But basically, automation is about looking after themselves and picking solar, wind or wave power, lowering the sail when there's too much wind or there's not enough wind, optimising whether you're going for solar power or wind power. And basically, we've currently got 2 or 3 people looking after 10 robot boats. So we've got, right now at this very moment, we've got 9 blue bottles in the Timor Sea being operated by the Royal Australian Navy. And we've got about 3 people looking after 9 or 10 robots. We've got a room full of people trying to get that down to so that 2 or 3 people can look after 20 or 100 boats. So for automation for us is about them looking after themselves. And when we lose comms, which we do from time to time, and in a conflict with Navy or with defence, the comms might be one of the first things you lose. So these things have got to actually talk to each other, shout out to each other, update each other with a well view, and we talk about it like a soccer team, so that the coach has told them the rules of the game, they have a game plan, and they don't need to talk to the coach if the opposition does something different or the environment changes. And I'm just saying also, the other thing we're doing, and like satellites, is our boats are like 300, 400 miles at sea, so if something goes wrong, our software guys have got to fix that remotely. And recently we had an incident where we had something go wrong, and we tested it on blue bottles on dry land 22 times, and it worked 21 times out of 22. And then we fixed it on the boat at sea, and it worked. And I'm saying, well, if you're at the casino with those odds, you'd bet on that every time. But there was a chance it wasn't going to work. So that's the sort of exciting stuff that our guys are doing. Thank you.
Anne.
Yeah. Really good points that Robert's made. So kind of similar things in space. But what tends to happen is space is very far away, and as satellites orbit around the Earth, we sometimes lose communications as well. And this is kind of sad for the little satellites floating around on their own when they don't know what to do. So what we're trying to enable at Deneb Space is the smarts for satellites to be able to make their own decisions, to stay on track, to be really stable. If something's approaching them, they can perform collision avoidance, like as you're saying, if the opponents change, what happens? But because traditionally what we've seen is sort of in the 60s, satellites are operated very manually, and I mean that worked in the 60s, but we're still doing that today. And as I've shown you that lovely graph, we're seeing that there's going to be more and more things in space. It's just not going to be practical or scalable to do that. So there's this real need for autonomy to maintain this infrastructure that literally billions of lives depend on every day.
That's great. Now, I'd love to shift to where your companies are currently focusing, because what we've come to understand is each of your technologies has a really broad applications across many, many industries. But, classic deep tech, you need to start somewhere, right? So where is your current focus for your technology? Maybe, Robert, you can start with us. I think you said about some work you're doing with defense. Where is the focus for the OCS team and the technology right now?
We've got a Terra Level 9 product that's done 40,000 nautical miles at sea in the last 2 years.
Wow.
We're focusing on scale up. We've nailed, 95% right design of the hull. We've just built a new mould that can build about another 300 boats if we need to, but the insides of those boats will change. So we're looking at using the same product for non-defence applications, and we're looking at marine mammal monitoring, which we're doing in America with an American company. We've got 2 blue bottles over there. We're looking at hydrography because it's disruptively cheap to map the oceans, and we know more about Mars than we know about the oceans. And also oceanography is a huge area that climate science and hundreds of people around the world want data, but they don't want to run a boat, and they don't want to operate a boat, and they don't want to drive a boat. So we're looking at data as a service. So that's the focus for us at the moment, is to use the same platform, different insides, different sensors and payloads, and different applications.
That's great. Now, Clyde, I know you've got an application you're working with Transgrid. Is that right? That's a current focus for you. So tell us a little bit about the work you're doing with them and the industry that you're focused on in the energy sector.
Yeah, absolutely. So energy transmission is something I've been looking at for a long time. There are scaled issues with how we perform maintenance on our now very aging energy infrastructure. Yep. The general plan is to run it all into the ground and replace it. For anyone who's not aware, it's extremely disruptive and unsustainable. And that's really because that's the economic operating point. and that's fine. That's a perfectly reasonable business decision. What robotics will enable us to do is really flip that on its head, make maintenance of not only our energy infrastructure, but society's infrastructure in general a lot cheaper, right? So my goal in 20, 30 years time is for all of you to wonder, why is everything so well kept? What's doing it? And I'll have all these robotic systems, in the background doing all this work, and you'll have forgotten why that even happened, and I'll be off on a yacht somewhere.
Powered by OCS.
Yeah. What we're doing immediately, our first product is essentially a four-wheel drive for high-voltage transmission. So this is something we've sold to Transgrid, and it's going to be helping replace our energy conductors. So our actual transmission conductors, they're 60 years old, they're very degraded, and so we've provided a tool to Transgrid to help them replace conductors to both just sustain but also upgrade the transmission network as we try to connect more renewables and build higher loads. We've made that process safer and cheaper.
That's amazing. And you started this business when?
18 months ago.
Incredible, incredible. Now, Anne, talk about some of the focus for you right now.
Yeah, so
Deneb Space.
at Deneb Space, so we're hardware and software integrated together very well, but excitingly, we actually have a piece of hardware launching to space in 2 weeks, so that's pretty exciting for us. But in terms of what that means is we're basically proving and validating that hardware, that it's providing the efficiency and the precision that we're enabling. And the end user for this application is agriculture and sustainability. So monitoring Earth, getting more data, better quality data, and also having a longer mission lifespan because we're very efficient in what we do and we keep our satellites on track so they're not drifting off. And that's what we've been focusing on, so that agriculture and sustainability industries that we've heard about all the fantastic people doing, supporting that today as well.
Yeah, so you're supporting some of the Tech23, the work they're doing too. So let's fast forward to the future, because we like talking about the future here at Tech23. I'd love to think about what's on the roadmap for what's the opportunity. Maybe it's even a surprising application that we might not be thinking about, but maybe you could each share where is the real possibility of industrial disruption for the technologies or enablement even that you're working on? So maybe, Anne, I'm going to start with you. What can you tell us about the 10, 20 years in the future?
Yeah, so we've got a really interesting kind of market segment. So we've got where we're working directly with the satellite manufacturers. Our system, as I said, it's really, really efficient. So we're providing 5 times the amount of rotational torque for 1% of the power consumption. And what this means is satellites are using less fuel, they can stay in orbit longer, so really enabling that infrastructure, providing that precision there. But then the kind of other side that's really cool is those end users, as I said. And one that we really, really feel passionate about enabling is kind of looking at when there's a disaster relief, like having information to do that. So, bushfires, flooding, can we have precise data looking at long time periods with high revisit rates? That's what the sorts of things we want to enable.
And that's going to be so critical because unfortunately we are going to be facing more and more disasters. So that's amazing.
Exactly.
Clyde, take us forward 10 years, 20 years.
10 years, all right.
Tell me about because you've got a robot that mimics a parrot. Where else have we got? What's some of these, Tell me, where am I going to find Crest Robotics deployed?
All over the Earth and all over the solar system, I think. So we got some really exciting partnerships with different companies. So one of the ones I like the most is a giant spider-like robot that 3D prints houses. Different form factor using really sustainable materials, and that's with a partner called EarthBuilt. We're also planning to do that on the moon, which will be really exciting. So it's a really sustainable and only uses the material around you to build these structures. So that one's going to be awesome. But I think sort of the most disruptive thing we're going to do is create new jobs. So in 10 years' time, what you're going to see is people calling themselves robotic operators or something to that effect, right? Where there's TAFE courses available where they can go and do work. And you'll have, instead of people just getting on construction sites using the tools themselves, they'll be in charge of operating these advanced robotic machines. They might sort of be looking after 2 or 3 at the same time. They'll be connecting the tools and then intelligently sort of orchestrating these machines to get the work done. And I think that's something I'm most excited for because it will really disrupt the construction industry. In terms of think about who generally is in the construction industry in the moment. It's pretty dominated by one of the sexes, and that's for a lot of reasons. But what a robotic operation does is increase the accessibility to these sort of jobs. It favors intelligence over testosterone, for lack of a better way of putting it. So that you've got people that are very safety focused, are operating from a place of comfort and not putting themselves under duress to actually deliver work.
Amazing. And I love that. It's enabling even better jobs for people, which is what we want in the future. Robert, OCS, tell us.
We've lived Moore's law for the last 20 years. Every 2 years, things get twice as good, half the power, half the cost, half the weight, and twice as good. And it goes. So, what will be happening in 10 years or 20 years is I'll get the timing wrong, but it'll be more and more. Okay, imagine a network of blue bottles across the top of Australia, or down in the Southern Ocean, or across the Pacific, or wherever. They'll be doing more and more. Above the water and below the water, sensoring and dataing and integration of this massive amount of data and combining it with satellite data and Internet of Things. And then if you look at soft robotics, then all sorts of organic looking fish and octopuses could be swimming around that are robots that are also collecting data and talking to the blue bottles and, not running on solar and wind power, but actually eating fish or something to power themselves, which might be bad for the fish in the oceans. But so it's really hard to predict the future because of that whole Moore's law thing. But that's with the blue bottles. Then there's the Ukraine type drone that we've got some development in. There's another looking at a product where we could give something to every sailor that just they carry on their boat. It's runs on solar power and it puts them in part of this data network, and they can be feeding data into this network. And then for Clyde, for his when he retires, when I retire, imagine a 30, 40, 50, 60-foot yacht where you get on board and you just ring up OCS and say, take me to Fiji. Or by the way, can you take my boat to Fiji, and I'll fly there and I'll meet it there. So there's a whole bunch of things.
Painting a really nice picture for us all there, Robert. So we've got octopus robots and then spiders that build homes. That's what we're talking about the future so far. That sounds really exciting. Now, we are about to hit time. So as we close out, we've been asking people if there's an action you'd like anyone in the room to take, a change you believe is crucial to help your businesses. I'm going to go down the line, starting with you, Clyde. What can we do to help you?
All right. I'm always looking to chat to investors, but really customers over investors. So if you know an executive that's got problems with risk or liability, with workers doing dangerous jobs, I can help.
Customer focus. Anne?
I'd probably say the same thing, always looking for investment. That's always quite nice. But mainly as well, customers, those end users that can see the real tangible benefit of what we're offering. We want to help as many people as possible. We've got the tech, so let us use it.
I need a hand to renovate a tram shed at the University of New South Wales campus at Randwick. It's got asbestos in it.
It's a very specific ask.
It's 300 metres from where we are. It's on the university. I need to talk to the university.
Maybe one of Clyde's robots.
Yeah.
Get
the spider robot in.
Yeah.
That's my immediate job.
Amazing. Well, we are at time. Please give it up for these incredible founders. Thank you to Clyde, Anne, and Robert.